Hello Math 7 students, this is Utah Middle School Math Project 2.1b, add integers using a number line. We've hinted at this in some previous lessons. Now we're officially going to have some direct instruction on how we're going to add using a number line. Some things that are worth mentioning right now. This is Utah Middle School Math Project, so we're going to see this in our grade system as UMSMP 2.1b. So what we have here, I have 4 situations. I want you to answer the question the best that you can using pictures, words, explaining how it is that you arrived at your answer. There needs to be some group discussion as you do this. You might choose as a group to model them in different ways, but I think that group discussion really helps us to understand what's happening, and then we can decide how to model independently. An osprey flies off the ground and reaches 35 feet above a river when he sees a trout. He then dives 37 feet down to get the trout. How many feet below the water does he end up? That's your first one that you'll discuss. The next one, Zach's football team moves the football 35 yards forward on the first down. On the next down, they lose 12 yards. On the down after that, they go forward 8 yards. How many yards from the starting point did they move the football in 3 down? A lot of you might say, I have no idea when it comes to football. That's okay. There are enough context clues like moving the ball forward or losing yards. So even if you know nothing about football, focus on the other context clues, and maybe there is someone who can explain football to you in your groups. The next one, number 3. You walk 3 miles from your house to the store. At the store, you meet up with a friend and walk with her 1 mile back towards your house. How far are you from your house now? And the last one, you ride your bike 12 miles and then get a flat tire. You turn around and end up walking the bike 4 miles before your mom is able to pick you up. How far are you from the house when your mom picks you up? Those are your 4 situations that you're going to talk at your tables. You are going to do your best to answer the questions using pictures and words and models to help you get those answers. We're going to pause the recording as students work in their groups right now. Ready, set, go. All right, an osprey flies off the ground and reaches 35 feet above a river when he sees a trout. He then dives 37 feet to get down to the trout. So I'm going to draw the river. I'm going to draw a bird. It's a beautiful bird. And that bird is 35 feet above. But what happens when that bird sees that trout? He dives down. How much does he dive down? 37 feet. Where's he going to end up? He's below the water because he's only up 35 feet. So if he's going down 37 feet, why did I put 5? That's weird. 35. He now ends up below the water. And exactly where below the water is he? I heard the answer. He is at -2 or 2 feet below. Who represented it in a similar way? Drew some sort of a picture. Okay, great. Who drew chips and tiles? Yeah, do you really want to draw 37 positive tiles just to then draw 37 negative tiles? No. So I'm not there yet, but this is kind of almost sort of looking like a number line representation, right? Wonder why, if it's the title of the lesson is using number lines. I wonder if we could represent this next one in a number line sort of way. Zach's football team moves the football 35 yards forward on the first down. I know nothing about football. I do, actually. But I know that 35 yards forward means I'm probably going to be moving, I don't know, in the positive direction forward. What do you guys think? All right. On the next down, they lose 12 yards. So this whole down thing is kind of confusing for someone who doesn't know anything about football. But again, the context clues tells me that if they lose 12 yards, what direction are we going to be going? Back. Which direction would you say if we're using math words? Negative, yeah. We're going to be going to the left. We're going to be going negative. And then on the down after that, they go forward 8 yards. Again, I might not know a whole lot, but I know that going forward tells me I'm going to be going in this direction again, right? Where is that ball? Where is the team after those 3 downs? let's break this down. We go forward 35 yards. Sorry, did I say 34? Even people listening to the recording are going to realize I make a lot of mistakes. We go forward 35 yards, and then I'm going to go back 12 yards. So where am I right now? Right now, before that third try. Yeah, I'm at 23. Am I drawing all of the numbers in between? No. Do I have to? No. And now if I'm at the 23 and I go forward another 8, where am I going to end up? 31. Now, this is for those who actually know things about football. Does that mean we're on the 31-yard line? No. It just means that we're 31 yards ahead of where we started. All right, next one. You walk 3 miles from your house to the store. I'm probably going to draw a house. And I'm walking to... Caleb said, I did too, but my drawing doesn't look anything like Caleb's. Caleb's is probably way more amazing than mine. Walking to the store, and the store is just going to be a big box. Stores are, generally speaking, a bit bigger than houses, right? All right. So I walk this way. I go towards the store, and I walk 3 miles. But then I meet up with my friend. My friend doesn't have any arms, but they do have hair. I meet up with my friend, and now I'm going to walk back towards my house. I'm going to walk back towards my house. Sure, that's her arm. A 1 mile long arm. Where are we now in relation to my house? Where am I now in relation to my house? Annalie? Yeah, 2 miles away. And this last one is the worst situation of all. You bike 12 miles and then get a flat tire. You're 12 miles away from your house. When this happens, I don't even think I want to attempt a bicycle. This is going to be really... I'm not going to attempt a person on the bicycle. Here's the bicycle, and here is my house again. But my bike is now 12 miles away from the house. And now I need to stop my bike ride, and I need to start heading back home. Mom says, yeah, I'm still at work. You're going to have to make your way home. But I do make it 4 miles back. How far away am I still when Mom finally catches up to me and can pick me up? 8 miles away. Okay. Not carry. You can wheel your bike. You just can't put any weight on your bike when you get that flat tire. So the thing I like about these problems is these problems naturally make us think of number lines. Some of them are very linear, where we walk on the ground, whether we're playing football, we walk on the ground going to a store, riding on the ground, or even this one where we drew our number line vertically. It still is very indicative as we're trying to model these. We just think of number lines. We think about changing our position instead of thinking of chips and tiles. And so that is the lesson today, is how can we use number lines to help us answer these questions. So we want to make these connections between the chip tiles and the number lines first. So go ahead and turn your page. We're on the next one. Let's make some connections. The first one is already done for you. So I have -5 plus 4. We'll start with our chip tile model. Here's our 5 negative tiles. Here's our 4 positive tiles. We can see I would find these 0 pairs, and I would see that the end result is -1. Because there's 1 negative unit tile. If I'm looking at the number line, there's not a story to tell here, not like we had on some of these other ones, but I still understand that if it starts at -5, imagine our magical floating basket. Our magical floating basket would start at 0, but then our magical floating basket, because of these 5 rocks or these 5 negative tiles, that would go down to -5, right? Now turn your head on its side, and now you can see this number line. That means our magical floating basket is going down to -5 because of those rocks. I've just turned my head, and now it's sideways. But then I add all of these balloons. And when I add those balloons, that makes the basket float up. So that's me adding those balloons, going up 4. And where do I end up? Still end up at -1. So there's our 2 representations. Will you try one on your own with your tables? Number 5, can you now model 7 plus -3 on a number line and with chips or tiles? So here's your number line, chips, tiles below. Once you do that, if you finish early, you're going to continue on to number 6. Can you explain how those models are related? Pause the recording as you talk at your tables. Ready, set, go. All right, I've modeled the chips and the tiles. This is very familiar to us, so we can check that one pretty easily. Let's take a look at how we would model this. It says 7. So again, I'm imagining 7 balloons. That's going to make my basket float up, or this time the basket's going to float to the right, 7, because of those 7 balloons. But then I'm adding in all of these rocks. And as I add in the rocks, 1, 2, 3 rocks, it makes the basket sink down, or in this case, it's moving to the left. So I get, no matter which way I do it, 7 plus a -3 is equal to a +4. Okay. I now need to discuss, how are these number line and chip or tile models, how are they related? Do you see any similarities between them? Talk at your tables? Or let's see, you guys already talked at your tables, so we should be ready to discuss this. All right, tell me, how are these models related? Yes, Cameron. All right, so negative sounds like a bad word, right? Because it's negative. So you're saying the good ones are the ones that make us go up or to the right. The bad ones are the ones that make us go down because they're negative, or to the left. Yeah, that is related in both of those. Let's go, Lily. Yeah, same things, same numbers. Do you see 0 pairs in each of these models? Yeah, we can see the 0 pairs here. Where do I see the 0 pairs in our number line? Yeah, it's where those 2 lines are overlapping, right? Those end up representing 0 pairs. Okay, I'm not going to write that down. Good enough discussion. Let's actually do some of this work. Again, our first set of problems were very, we just felt like a number line was the right way to represent them. These, we're taking out that context, but I want us to really practice representing them with the number lines. So the key thing to be successful here is you gotta know how to count. That's the biggest thing. You gotta know how to count. So on our first one, it says 6 plus a -3. Something to make note of with these directions. On all of these, it tells you circle the operation. Let me come back. The title of this lesson is adding. So what is the operation that we're going to see throughout every one of these problems? We are going to be adding, but it's still probably a good habit to get into to acknowledge we're adding, because we're not always going to be adding. Pretty soon, we're going to switch over to subtraction. And we have to look at these problems differently. So right now, we're going to acknowledge all of these are addition problems, and now let's find the sum. I'm going to begin with 6 balloons in my basket. So it was at 0, but those 6 balloons are making us go all the way up to 6. To show what happens now, the basket is now at 6 because of those balloons, but now I'm adding in these extra rocks, and the rocks make the basket reverse and go in the other direction. Now it's time to count 1, 2, and 3 backwards. Where did I end up after doing that? We can see that we ended up at 3. Now it doesn't matter if our number line is horizontal or if the number line is vertical. The process is still the same. Up and to the right represent the positives, down and to the left represent the negatives. So number 8, same thing. 3 rocks in the basket, -3. So I'm going to draw an arrow that shows where that basket has moved to. Down 1, 2, and 3, down to -3. Now from there, I am adding in some more rocks. So the basket still is here at -3, but now I've got to count 9 more spaces down because that's how far we're going down. 1, 2, 3, 4, 5, 6, 7, 8, and 9. If I drew that correctly with careful counting, it looks like I ended up at -12. This will probably be the last one that we do together before you guys get to practice on your own. What about number 9? I can see I'm starting at -12. That means those 12 rocks have already made the basket sink all the way down here to -12. This time I'm adding balloons, and when I add those balloons, that's going to make the basket go back up. This is the part where we have to be careful. Let's make sure we're very carefully counting. 1, 2. I'm going to jump up to the 5. That means I've made it to 7. I'm going to keep on going. 5 more. Means I've made it to 12, but how many balloons have I added? 2 more. And that, do you notice the thinking that I just modeled out loud? Do you notice what I did? I paid attention to this part right here. I paid attention to the 0 pairs. If I'm starting all the way down at 12 and I'm going to be adding 14, I'm going to have 12 of those 0 pairs. So really all I then need to focus on is how much further up I need to go, how many extra balloons are going to be there pulling that basket up further. So -12 plus 14 is equal to a +2. That's it. That's how we're going to model these with number lines. The key thing, we are stacking our arrows end to tail, or end to tip, or tail to tip. There's so many ways that you can say that. When I'm ready to draw that second arrow has to start where the first one left off. As long as you're doing that, then you will be successful. I'm going to pause the recording, give students a chance to work through some of these, and then we'll come back together at the end. All right, students in class have already worked on these, but they've also left for the day, so I'm going to continue these just quickly showing the answers without any student responses. -4 means our basket has sunk down to -4 because of those 4 rocks. I add another -4, so it continues to sink down 4 more, and now I am at -8. Again, notice these arrows, the second one started right where the first one left off, just like our basket is going to go down, and then from that point it's going to go down some more. It's not going to switch positions. And number 11, we start at +9. So those 9 balloons have pulled the basket all the way up here. And again, here is the biggest challenge, is trying to count down 25 when the marks on that number line are so low, so small. So let's give it a try. When I'm at 9, I'm going to go down 9 spaces, and I know I've made it down at 9 spaces because I have ended up right here at 0. So from here, I just need to continue counting. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. Again, that is tricky, especially when I'm doing these kinds of arrows. If you're a little bit closer to that number line, it's a little bit easier, but it looks like I made it all the way down here to -16. So it doesn't matter if these number lines are horizontal, meaning they're going left to right, or vertical, meaning they're going up and down. We're going to start each one of them tip to tail. Here's our final problem before we go on to homework. I have already created a number line. With that number line, you need to figure out what is the numerical expression and what is a story that we could tell. Students in class came up with the numerical expression of 15 plus a -20. 15 because this first arrow starts at 0 and goes all the way up to the 15. And from there we count 20 spaces backwards until I landed at -5. So the numeric expression is 15 plus -20. The result is this is equal to a -5. There were some interesting stories. One that I really liked was You deposit $15 or you add $15 to your bank account. And then after you've added $15 to your account, then you spend $20. If we're spending more money than we have, now we are going to be in debt. And so the result is we now are in debt $5. That's it for this lesson. Today's homework, the homework for this lesson is 2.1b homework section. It looks like there's about 7 problems. Most of them are number lines. The very last one, you will be creating a context or creating a story, as well as creating your own number line and a numeric expression. That's it for today. Thanks for watching. We'll see you next time.